In Chapter 7, we looked at return on investment. In this chapter, we need to add the next level of calculating return on investment, and that will involve using discount factors. The issue is we don't always get the return on an investment immediately. It often comes sometime in the future. To identify the fact that value in the future is worth different than value in my pocket today, we have to discount that future value back to today. How do we do that? Suppose that this is the value you make an investment, and this is the value it's going to be tomorrow. Well, this is the investment you make today, and it earns an interest rate of R. So the value tomorrow, or next year, is equal to the current value today plus the current value times the interest rate. We can rewrite this simply as the value today times 1 plus the interest rate. So that's here. The value tomorrow is equal to the value today times 1 plus the interest rate at which it accrues extra value. We'll divide both sides by this, so it ends up here, and rearrange the equation, and you end up with this. The value today equals the value tomorrow divided by 1 plus the interest rate. We define that factor of 1 over 1 plus the interest rate as the discount factor for year 1. It's the indicator of 1, d sub 1. The discount factor for year 1 is simply 1 over 1 plus the interest rate. With this discount factor thus defined, we can say the value today, here, is equal to the value tomorrow, there, times the discount rate, because the discount rate is 1 over the 1 plus R. 1 over 1 plus R is the discount rate. So the value today is equal to the value tomorrow times the discount rate. Why would I use this? Well, so you're a marketer and you're perhaps advertising, but you don't expect people to purchase immediately after seeing the advertisement. You expect to build brand awareness, and they'll purchase over the course of the year, perhaps at the end of 6 months. Well, what's the value of them purchasing in 6 months? What's the discount rate that you apply? The interest rate that you apply? That'll determine the discount factor, and that can tell you the value of the advertisement today, even if they purchase 6 months from now. That's one example. Another example is you're selling something, and what you're selling has a cost today, but delivers value to the customer tomorrow. Well, if it delivers value to the customer tomorrow, but it has a cost today, they need to compare the cost today to the value it delivers tomorrow. Well, they're going to have to discount that value it delivers tomorrow back to today. How do you do that? You find the value it delivers tomorrow times the discount factor, and that tells you the value it delivers today in present value. What if you have longer periods of time? Well, you just keep multiplying that 1 over 1 plus R. So years for 2 years, and that's 1 over 1 plus R squared. In general, for any year, the discount factor is 1 over 1 plus R to the n. So now you can even get more complicated and imagine it delivers a dividend or it delivers value every year for the next 5 years, but it has an upfront cost. So it has an upfront cost, that's the price of the product. There's the price of the product, but it delivers value every year at the end of the year. Well, let's go ahead and discount all of that back to our present value to find our financial gains. And from this, we can actually calculate out our return on investment. Shall we see an example? All right, let's take an example of calculating the net present value of an investment or of a purchase of a product. Suppose here's a blank spreadsheet, and what is it? What are we told? We're told that a business customer is evaluating a purchase of a $25,000 piece of machinery. So therefore we know our cost. And that cost is $25,000. And that lasts for 5 years. So our years is 5. What else are we told? The customer anticipates the machine will begin to save her firm $10,000 each year at the end of the year. So savings and savings is 10,000. Let's go ahead and put this in dollar signs. So there's my dollar, and there's my dollar signs. Excellent. At the end of each year, because of the time value of money, she knows she must discount those future savings. Let the discount rate applicable to the firm be 15%. Therefore, my rate, R, is 15%. Excellent. All I am is typing in the data from the word problem we're given, representing the borrowing cost of the firm. So let's see what our current value is and our net present value is, as well as applying our discount factor. So here's year, and here's my discount factor. And let's make this column a little bit wider. There we go. Year 1, 2, 3, 4, 5. So at the end of year 1, my discount factor is equal to 1 divided by, how much is 1 divided by 1 plus the interest rate. That'll do it. The end of year 2, I'll take that 1, I'll divide it by, open parenthesis, 1 plus the interest rate, and then I have to square it. We can do it that way. Copy, paste. I'm going to show you another way. Just move this over. We could have also taken this 2, and that's the year. I could have done that. See, you get the same number, comma. There you go. I could have also just done equal to what I had above, divided by 1 plus my interest rate, close parentheses. That leads to the same thing as well. So here's 3 different ways of calculating this factor. Take the one above and divide by 1 plus r. Simply divide by 1 plus r and raise it to the power of the year, or do it manually. I like this method. Copy, X, paste. Because I can just copy and paste that straight on down. Whoops. Only if I have my dollar signs, right? Copy, paste straight on down. And those are my discount factors for every year after the first year. We also know our savings, future savings for every year, and that is equal to that $10,000. Correct? Correct. So that means my present value of savings, present value of those savings is simply my savings times my discount factor. So $10,000 at the end of year 1 is only worth $8,600 today because of the time value of money. I don't need to put any dollar signs on this case. I'm going to copy and paste all the way down. So we now can find our total present value from this machine equals the sum of everything above it. Those are all my savings over the 5-year useful lifetime. Oh, wait. My 5-year savings over my useful lifetime, even discounted back to today, is greater than my cost. It looks like this person should purchase the machine. I can also calculate my net present value, and that is just simply equal to my total present value less my cost that I have to pay up front. You see that right now, if I purchase this, I've already gained $8,000 in terms of total value. That's my net present value. That's saying, another way of saying this is that it cost you $25,000, but it's worth $33,000. The difference is $8,000. So should you spend the $25,000? Yeah, because it's worth $33,000. Excellent. Now, if the net present value is the financial gains less the financial cost, we can also find our ROI, our return on investment, as our net present value, financial gains less financial cost, divided by the financial cost, and put that in percentage format. And there we see we have a 34% ROI. Should you purchase that? Yes, because for every dollar we invest in this machine, we get $1 plus 34 cents back, or $1.34 back. Our ROI of 34% implies for every dollar we invest, we make $1.34 back. That, to me, sounds like a pretty good investment. Armed with this knowledge, you should be able to do the trade show advertising exercise, the monument etching machine exercise, and the employee training exercise. Good luck.